You ever look at a modern airplane or maybe a super sleek sports car and just wonder, how on earth did they do that? I mean, the curves are perfect. Every single part fits together flawlessly. It honestly seems impossible. Well, today we're going to pull back the curtain on the software that actually makes the impossible possible. Right. This is the big question. It really gets to the heart of the challenge for engineers in huge industries like aerospace and automotive. When you're dealing with people's lives with massive, massive investments, there is absolutely no room for mistakes. So, how do they pull it off? Well, the answer, for a ton of the world's biggest innovators, actually lies in one single, incredibly powerful tool. So let's get to know it. Let's talk about CATIA. Okay, so CATIA, and that's a mouthful, it stands for Computer-Aided Three-Dimensional Interactive Application, is a software suite from a company called Dassault Systèmes. And you gotta understand, this isn't just another design program. It's become the fundamental go-to tool for anyone trying to build the next generation of really complex machines. So what is it that makes CATIA so special? Well, it all starts with its amazing ability to handle incredibly complex surfaces. It's all about turning a designer's vision into something you can actually build, a tangible, manufacturable reality. And this, right here, shows a massive leap in what's even possible. You know, designers used to be stuck with these kind of boxy, simple shapes because they were limited by physical drawing boards. But now, we're in a world where they can create these fluid, aerodynamic curves that are absolutely essential for modern performance. CATIA is what unshackled them from all those old limits. And this slide really nails the real-world benefits. We're talking about meticulous, down to the micron accuracy, which makes sure every single component fits perfectly. This is what allows for those amazing, innovative shapes we just saw. And maybe most importantly, it slashes the risk of these hugely expensive errors later on. Precision isn't just a nice to have, it's an absolute must. But here's the thing. Modern engineering isn't a solo act. Not at all. It's a massive team sport, which brings us to the next big idea, collaboration. And this is another area where CATIA just shines. Just think about it for a second. Building a plane isn't just about the metal frame. You've got mechanical engineers designing the structure, you have electrical engineers running all the wiring, and then you have systems engineers integrating the flight controls. All of these different teams have to work together in perfect harmony at the same time. And here's how that actually works. So the mechanical team designs the wing. While they're doing that, the systems team can jump into that exact same digital model and integrate the controls. Then the electrical team comes in and adds their wiring. But the real magic is step 4. All of that data updates in real time for everybody. This prevents those nightmare scenarios where things don't fit, and it keeps the whole project moving at an incredible speed. Now, this whole idea of a single, real-time model leads us to one of the most revolutionary concepts in all of modern engineering, the digital twin. So what in the world is a digital twin? Well, to put it simply, it's a perfect one-to-one virtual copy of a physical product. But it's not just a pretty 3D model. It's a dynamic simulation that acts and reacts exactly like the real thing would. So yeah, it's not just for looking at. It's really about creating a living, breathing digital version of the product you want to build. And having that allows for a whole new level of testing and analysis that was just impossible before. And the advantages here are just staggering. Think about it. In old days, you had to build these super expensive, slow, and often one-time use physical prototypes. With the digital twin, you can run it thousands of tests, stress tests, aerodynamic simulations, systems checks, instantly and for a tiny fraction of the cost. It completely flips the economics of innovation on its head. But this level of digital mastery isn't just about making things faster or cheaper. It's also about making them better. Better for us and better for the planet. CATIA is actually a really important tool in the push for more sustainability. Because engineers can use these advanced tools to meticulously shave weight off of parts, gram by gram, which drastically cuts down on fuel consumption over the life of a plane. They can digitally test and validate new, greener materials without doing a bunch of wasteful experiments. And they can optimize every little aspect of a design to reduce emissions. And hey, this isn't just good for the environment. It directly lowers the cost to operate the product over its entire life. This all ties into a bigger concept called Product Lifecycle Management, or PLM. Basically, CATIA lets companies manage a product from the very first sketch all the way to its eventual retirement, making sure every single stage is optimized for both efficiency and sustainability. It's the whole shebang, the complete long-term strategic view. So here's the main takeaway. From the perfect curves on a supercar to the powerful wings of a jetliner, CATIA is the bridge between a visionary idea and a physical reality. It's the sandbox where incredible complexity is managed, where teams collaborate seamlessly, and where the future gets tested before it's ever even built. And that really leaves us with a fascinating thought, doesn't it? With tools this powerful, we now have the ability to design, test, and perfect almost anything you can think of in the virtual world. The only real limit, at this point, is our own imagination. So the real question is, what are we going to build next?